You might have heard before that ancient Greeks measured the circumference of the Earth using only a stick. That's right. And spoiler alert, not this way.
How then?
This bad boy, Eratosthenes, born in 276 BC in Cyrene, now part of modern-day Libya, was the chief librarian at the Great Library of Alexandria. He heard that at noon on the summer solstice in Syene, now Aswan, Egypt, the sun shone directly down a deep well, meaning its rays hit the bottom of the well at a perpendicular angle, meaning also that the sun was directly overhead and leaving no shadow. He wondered if this was also true in Alexandria, so he waited until the next summer solstice, which occurs annually on June 21st, and planted a stick vertically in the ground and waited to see if a shadow would be cast at noon. And there was a shadow, which measured an angle of 7.2 degrees. So, if the sun's rays are coming in at the same angle at the same time, and the stick in Alexandria is casting a shadow while the stick in Syene is not, it means that the Earth's surface is actually curved. Already knowing that the Earth was spherical in shape, depending on the notes of Aristoteles, that when a boat sailed from a harbour, and the boat looked like it sank deeper and deeper into the ocean, after a while only the masts were visible. The conclusion was that the water, despite it looked like it was flat, it was a softly round hill that the boats disappeared behind. Since the effect was the same if the boats were going in any different direction, then the rounding is the same in any direction, and the sphere was the only body that explained that. Eratosthenes realized this could allow him to calculate the circumference of the Earth. Since the difference in shadow angle is 7.2 degrees between Alexandria and Syene, that means the two cities are 7.2 degrees apart on Earth's 360-degree surface. Eratosthenes measured the distance between the two cities, which measured 800 kilometers. He then used simple proportions to find the Earth's circumference. 7.2 degrees is 1/50th of 360 degrees. So 800 kilometers is 1/50th of Earth's circumference, meaning that 800 times 50 equals the circumference of the Earth. 40,000 kilometers, which is less than 2% different than the exact modern figure of 40,075 kilometers. A couple of decades later, an even smarter Greek dude called Aristarchus used the piece of information presented by Eratosthenes to measure the size of the moon. Knowing the Earth's circumference, and therefore the Earth's diameter, Aristarchus observed its passage through the sky. He calculated that while moving in the sky, the moon takes 1 hour to cover the distance of its own diameter. Once he'd worked that out, he wanted to figure out how big is the moon compared to the Earth. He realized that he could exploit a phenomenon called a total eclipse, which happens once or twice a year, when the moon passes through the Earth's shadow. Assuming that Earth's shadow is the same size of Earth itself, which is not 100% true, he asked himself, could he fit 1, 2, or 3 moons in one Earth's shadow? All he needed is to time how long the moon spins in the Earth's shadow, meaning how long we can't see it for during a total lunar eclipse. He measured that the moon took about 2.7 hours to cross through the Earth's shadow, and since the moon covers the distance of its own diameter in 1 hour, he knew that the Earth's shadow was 2.7 times larger than the moon itself. Knowing that, Aristarchus's calculations showed that the moon was 4,800 kilometers across in diameter, and we now know that the true figure is just over 3,200 kilometers. This is like 65% accurate. But at least he had kind of an idea of how to figure that out. The reason for the inaccuracy was that the sun is not a point of light, it's an area of light. This means that the sun casts the soft shadow, which is not 1 Earth diameter, but 3/4. He also did not have an exact value for pi, which he used in his calculations. He used the right concept, but the inaccurate data. So, give him some credit. That is pretty amazing for a person who lived in an age where this thing was the highest hygiene technology available.